So, we get ourselves Rev 2 here. That is not relevant. Rev 2 in the drawings show our new 44 3/4 location for the hull. Everything else the same. And then overall I added wheels at 5 inches and a 3/4 inch surface because I just feel like it won't hurt to do. It's not going to be that much more weight, and sometimes you just run into problems one way or another without it. So we're at 66 when it's level from the surface to the deck stage now. And so all of our other modifications should work. And we've got this clearance here as discussed. And about that point, this circle won't ever brush those corners, I don't think. And if so, like I said, I can hack them down a little bit. I've got meat back on the menu, boys. So I'll rip those up in a minute. But for now, let's go get the holes drilled because I can get into the wood shop. So I'm just going to take a minute to touch on the incredible facility that we've got. So I was a participant in the technology program when I was here 20-something years ago. I graduated 20-something years ago. So this is all new, but it's along the lines of an improvement on what we used to have in a different place, in different sort of facility. But we've got a nice spray booth, panel saw, lumber storage, flammables. This is all at the high school level. So the wood shop, this is all new this year and last. Major overhauls, a little bit of wood turning, workbench and box building. And then in here we've got more tech, CAD, electronics, and I think this is like some kind of modular building system. Yeah. And gliders, robots, laser cutting, and 3D printing, and it's Dremel. Some other SLA printer stuff. Got a little CNC router here. Large format printing. And some framing, architecture type stuff. And then more CAD lab over here. And when I was here, we had Photoshop and there's some digital stuff here, artwork, and looks like trebuchet and other types of things like that, hydraulic actuation, and the benefits, the different pivot locations, the power and the efficiency and stuff that you gain. Just cool concepts. These are mousetrap powered racing cars. It's a typical project that they do. And looks like pressure rockets, bottle rockets. And I got some cool stuff in there. And I don't think I can get in across the hall. Maybe I can, but... So I still advocate for college education if you can get it, or tertiary education of some kind, especially between the hands-on mechanical skills, the building, craftsmanship, and, running all the different tools, hand tools, as well as CNC and rapid prototyping tools in this realm, because the interdisciplinary and the cross-pollination that can happen when you understand a wider variety of this stuff is kind of incredible. And so I like to see students having access to it at the high school level where I went to school. And and like I said, then the sky's the limit. You can do all your academic stuff as well. And these things are just, I think they're going to help you in the 21st century in any case. Well, across the hall, I guess I can get in here. So this took a little bit more doing, and they got it to be ADA compliant, it looks like, too, which is nice. It used to be short stairs up at the front corner of the room. So now we've got some locker action. I haven't even been in here since they did all this. And this will be small engine. They've got, all your major components for discussion purposes or comparison purposes, and all the appropriate, you get your manual and your toolbox and all the stuff that you got to know for show. Looks like a little shear, planishing hammer or something else, and some press, punch. It's like a, there's a name for it and I can't think of it right now. Anyway, it'll do an iron horse or something like that. I forget what it's called. Plasma cutter, CNC. The kids get into, and then looks like they get some stuff cut out of there. Got your high art happening, and then welding lab, material storage looking good. Scrap bins, grinding, and run the door up and work on stuff. Bring a vehicle in here. Really nice facility that we've got. Just did a capital project here. We're gearing up to do another one, I guess. So this is how I like to see investments made into public schools. And I still like to see all of the great science Olympiad and STEM stuff, all the art facility and theatrical, musical, instrument and everything. I want to see an investment across the board. But it's exciting to see this. We made quite a lot of stuff happen when I was a student here, and a lot of people went on to do incredible things, and it wasn't anything like this. So I'm excited to see what happens now. All right, back to work. End up with a lot of pretty fantastic art studio. I mean, at the high school level, I think that, beyond status quo to a certain extent here. I can't get into the art lab, but they've got a pretty nice big room in this wing, and they get up to all kinds of great stuff. Digital stuff over here, and even clay sculpting, pottery and all that, with a nice view outside. And the stage is here, band and orchestra there, choral music there, and art on this side here. So we got this really cool loop all the way around the auditorium here on my left, where all the arts can kind of hang out adjacent to the lobby, which is pretty social usually. It's a nice school. It's a nice size, not too big, not too small. A couple hundred kids, 200 or 300 per graduating class. And again, this capital project, they've got like a radiant heat bus circle now. So this whole area of concrete has all got circulating glycol fluid in the concrete pore, so it doesn't ever build up a lot of snow, and you haven't got to salt it to death or plow it and tear it all to pieces and let it all fall apart. So I just added this piece here that I figured I might want, but I didn't draw out, you know. And mathematically speaking, if this thing is 33 overall, minus 11 for the 5.5 in each 6x6, we got an even 22-inch piece that went in there. I had to lift a little bit to put it in there, but I've said this a lot in most of my content. You're going to want to, in a case like that, make the part that's mathematically supposed to fit and install it and just continue to work like that. You start measuring and cutting to fit, you just keep building error in, you know, every step of the way. So now we've got a fairly nice assembly. There's some, you know, light showing here and there in some of the joints and some of the crackage, but like out here, if I pull on this, oh, I was doing it with both arms. Anyway, I'm lifting it off the floor over there. I don't have enough ass to put into it with both hands on it, but that's good. I want to see this right angle do that if possible, because it's truly got no diagonal bracing. So that means that right to start with, it's pretty rigid. Is it rigidly a little out of 90 degrees? Most likely. Will pulling it in fix that? Yeah, definitely. So with a very minimal amount of sticks, I have a good amount of rigidity here. And at this point, you know, you see me use the 10 and the 8-inch, and actually I think I used some 6-inch pieces in a couple places. Now, I don't understand why I ended up going 6 high, 10 low, 10 high, should have been 6 low, and 6 diagonally. It's gonna, you know, and in these cases here, it was 2 10s and an 8, and it all had to do with, and you'll watch me in the time lapse, try to find the center of an overall joint and try to come through that at a diagonal and have a reasonable amount of meat left without endangering, you know, coming out through everything. And again, approaching the grain diagonally in almost every case creates the strongest joint. Going straight into this and aligning to this grain here or this other direction here, far less meaningful connection. In fact, I wouldn't have been able to pull most of these heads, these nice big heads down in at an angle like that. That's demonstrating the power that I've got in the thread, the engagement that I've got when I can do that. If I spin out and I can't even pull the head in, I know that I've basically stripped the wood, and so most of these are sitting down. Now, I haven't gone to the point where it's perfect in every case because I haven't got to, and that's where you still can create enough buildup here to cause that to strip. So it's a happy medium, but for the most part, I'm seeing that pull in. It makes me feel real good about it. Now it's time to slap some wheels on there because I can't attach this other vertical in space, and I'm not going to tip this whole thing over and set it just on this tiny face on the other side to attach it while it's supported on the floor. And I don't have to because I'm not screwing up into it because that would have me going aligned into the grain. You notice I towed through these verts into this horizontal, so I'll be towing into this. So anyway, I can get the wheels on here, then I can tip it up and it's rolling, then I can put that second vert on and tow him in there, and all the other pinning that has been done. You know, if I need more, they can be added. I shouldn't, knock on wood, need to get back to the underside of this, you know, anymore. And that, you know, comes as a result of just doing a nice job while I'm here, because I know in the past I've always had to, even over here in the beginning of the time lapse, you see I threw a full 10-foot 6x6 down because I had planned on a 120-inch stick there. And of course, it's 120.5 inches. It's a little bit long. So I had to lift this end and take that little slice, that bread slice off of it to get to a perfect 120, and I did think about, just leave it, forget it. But that's another case of cutting to fit or not cutting in that case to fit would have made a mess of this thing. So you just have to police yourself. These are those far nicer screws to attach the wheels. Again, we were looking at these, and you know, obviously very similar. You can't get these any shorter. It's got a nice big head. I'm not even going to bother with a washer, I don't think, for these. I mean, we probably should, and we have some, but you know, probably will. So I'll pull some washers up, but we'll get the wheels slapped on this and then we'll tip it up and finish up just putting that on there. I'm gonna wait to get the pipe I got to order for tomorrow from the fab shop. I really rather line it right up with my hole saw before I go drilling, and then we can throw that in, and then we're gonna build that floor system, that deck, and Try to pop that up on top and see if this thing goes. All right, well, it's really pretty remarkable amount of rigidity, especially out here where these components are compromised doing the horizontal. So having the wheels underneath these verticals directly will be perfect. And then we can just keep racing out. And I got that pipe and stuff to put in here. So I'm appreciating the bare minimum and its structural integrity. So I know kind of how much more to add and how much to, skip out on doing. And this is a good example too of like over engineering, because I didn't do finite element analysis. This isn't trying to dial in the least weight for the most strength. I don't mind extra weight in this component because it keeps the CG low. Center of gravity stays nice and low. That being said, the extra meat beyond the pivot support and thereby the extra length in these braces, there's likely a dramatically shorter amount of side-to-side bracing that's necessary given the rest of the assembly. You could continue to shrink everything out to the most optimal kind of material cost point, and then we have the blocks of steel that could have been thrown in for weight. However, the 6x6 is a nice aspect here. 4x4, I just haven't got the ability to use the same kind of shorter versions of these structural screws and get the same like footprint for these verticals or footprint area for the caster wheel. It's just altogether not heavy enough. Excuse me. And once again, stick building and everything could have been, we could have utilized that, but it wasn't necessary at all. I think this is just a really economical way to do this. $500-600 worth of lumber in the major kind of components to that. And then, over $100 for these screws that we're not going to use. They'll go back. But among the 4 other lengths of structural screws in 50, quantity of 50 each, there's about $50 each here. So it's a little over $200 worth of those that we will likely keep. You can I always get the larger, the 50 count, because by the screw, it's a lot more cost effective. And then they have these 12 counts, 12 screws for all the different lengths. And so sometimes what I've done, if it ends up being mathematically worth it, I'll buy a 12 count of the same size and I'll throw it in to the box to complete the 50 and take the box of 50 back, which is 6 1/2 dozen really, and keep a handful, fewer than 12 or whatever around, and thereby reap the benefits of both scenarios. Whereas if you get the 12 box and you want another 2, say you get 12 and you need 24, it's as much as 50, I think, for these, one of the different lengths there. So it's wildly more cost effective to get the larger boxes. Still, a lot of money in hardware. I know a lot of people working in theater. This is a public school. This has got a budget for all the material costs in doing the set. And then the state's got a program to pay for professionals to contribute with arts and education. And, I get students and stuff involved here. They learn a lot. I'm an alumni. A lot of the faculty that participate in the show are alumni. We've got alumni in the pit orchestra holding it down a lot of the times. And so, these people and these things put shows on at the Center for the Arts across town in the summertime and off season, and Center for the Arts bring working professionals from Broadway in New York City and other places in as artists in residence, and they workshop their show, and then the students interact with them here at the school and down at the art center. And then when the students go on a trip to New York City, a lot of times they see the show that they were workshopping in town at the art center, where the students are familiar with the space and meet the people, and then they go to the city and they see the stuff. And we've had just a really nice relationship here with everything, and thereby there's enough money to be safe. I think you would agree that spending, like, what did I say, about $500, then $200 in hardware, and so we got like another $300 or so to spend on the, to keep it to $1,000 for this material cost on this big set. This is like the most complicated set piece that we're using. And then, we've got the stairs that have kicked around for some time now. We made an investment. The tree trunks, we made an investment a couple of years ago. We're just going to make a subtle additional, some changes to those to create more of a rock look. The circular base was from last year, but prior to that, the circle was from the year prior to that. These flats hang out, and, props and different things like that make the mirror. These sleeves we built for these rolling steel frames, and now, they make great flat walls, and now they make great little leg trim edges that come in. And I'm thinking we've got the 4 of them. We've got 6 rolling frames. I only ever made the 4 sleeves, but we're going to get another life out of the sleeves now the very next year, and then it may lead to doing more in the future. But I've got the ram board started on those to sort of round out. I want like what looks like the curve of like an undercut bank or something, or just the edges of a rolling kind of cliff face covered in corals and stuff that's going on up to the surface. And then we've got other columns of stone here, so we've got these like hollows in between those shapes, and then more of a vertical construction here, and then another hollow in between the shape that's kind of portals in and around and behind, and then the other bank kind of sweeping in here. However, I think that we might do the same thing on the other edge, and so then you can creep those out and have one look on them, and then turn it around and creep those out and have more of a spooky look from maybe Ursula. And so that, utilizes just the two different sides of the two. The other two, I'm thinking now there's a chance, because they have got, like this one, for example, has got the wainscot, the window and everything from last year. We've got bookcases on the other sides. But I'm just wondering if there isn't one that still has that same, because we could paint it this palace color. See, because we're going to bring this stair, that rolling doorway. I guess I gotta be, and we took that one apart, but not the end of the world. Basically come in a little bit utilizing the same idea, but keeping it plumb and finishing it the same as the inside of the palace, and supplementing the look of this piece that will be used as the door into the palace bedroom. Whatever colors and stuff this is painted, it's going to be what's on the other side of the biggest columns, because we're going to use those for different locations all over the palace. And so then I think we've got the circular component, the flat wall. We sneak a little bit of the walls in on those rolling flats at that time for different places in the palace. And we've got these planters and stuff too. I think it's an interesting way, right, to use the same kind of physical things finished differently, shown in different light, in different positions, to create such a wide variety of spaces, but it gives the show more of a cohesive feel. And I think that elevates the design. And, I didn't necessarily mean that. I just think that I know that would be the case. We're moving in that direction. Obviously, it's really nice to use and leverage investments that we've made previously. We all know that that's a good idea, so we're doing that as well. We made that hole in the stage, and we pivoted the set around it last year. There's a chance that we'll pivot the turntable around that. There's a chance that we'll pivot the ship around it, from looking at you where the stage is the water to looking on the other side where the stage is the deck of the ship. Remains to be seen, but just, after you get some tenure at a place and you start to build on what you're able to achieve each year and start to make plans, that will go this far this year because we can use that, but then we can take off and run with that next year. I think that that's wise. It remains to be seen what we're going to do with the 6x6. It'll be around, it's going to be really heavy and awkward. I'll probably take it down to the component parts, but hopefully there's another, opportunity to utilize it for something else, or, you know, you never know what might happen. But this is one of those rare times. Mamma Mia years ago, I didn't get any video coverage, but when I built Mamma Mia, you can see in my portfolio, we used 6-inch diameter circular fence post, and built this big modular rolling like deck that looked, you know, more like a pier or a dock, old school, and gave you the sense that you're down by the water in Greece. And with the rest of the set that year, it was a really kind of a cool look that we utilized that. Never came back to those circular 6x round posts. And so I'm just thinking of those this year, since we're kind of back to the same kind of technology, the structural screw and the big fundamental component parts. Didn't need to be treated, but of course that's what you can buy local. So anyway, I got to get the place cleaned up, which I kind of did. I did a little sweep. They've got dance rehearsal tomorrow morning. I won't be here until they're done with that. They can move the rest of this stuff around at their leisure. And then we'll get back to this thing. Try to get some more pieces on it, get the pipe installed, put maybe some of the deck framing together, possibly even put it up. I'll need some help to put it up though, so I might get stuck on that. I would love to see it up there. However, it would be kind of stupid to do that before I get the wheels under it, because I will have to tip it over one last time to get those other 2 wheels on. So I have to watch those. They're supposed to show up middle of this week. Tomorrow's Tuesday or Wednesday. And then, so toward the end of the week, I can get that sort of, you know, to a point where hopefully they can start to at least get it out here when they're doing their blocking for the dance around it. I probably need a little more time once they're back before I'm ready to put kids onto it. They usually like for me to have the railing or whatever guard, and sometimes I just slap something up out of 2x4 for the time being, just so they can start using it. I'm going to try to use those plastic bollard covers for railing system or something on the inside of the ship. And I've got some other stuff planned with that, so I'm excited. But for now, I got to get out of here today, and we'll get back to that tomorrow afternoon. Well, it wouldn't be musical season if this wasn't the weather. I love it, but, you know, there are better vehicles in my fleet than the rear-wheel drive 3/4 ton pickup. But this is what I got, so this is what we'll roll in. So believe it or not, I've got all these hole saws in this kit, and I've actually got quite a few more than this, but I mostly just have what's in here when I'm on the job site, unless there's something unique or special, which is where we are now. I'll just mention right now, see the little hot spots on those teeth? That's actually a flat surface. That's dull. And there's a bit of that happening on the next one in. And then there's some other more obscure ones. You can also see that the gullets are still painted. I mean, you can see that this is fresh and white, and that's all. You know, it gives you, there's a bunch of different ways to sort of establish this. You can feel of it, whatever. But right to start with, I immediately can tell that that outermost hole saw is smoked. You can keep trying to cut holes with it, but you know, and I keep it around because I can do 1 or 2 here to make sure of it being the right size, whatever, or in a pinch, and then I go get a fresh new one for that size. So you want to realize that so many of these things are costly. I mean, $15-20 for average size ones. That's going to be $60 or $70 on the bigger ones if you go with a nice brand. So anyway, I try to resist getting attached to them because they don't do very good work after a while. I had to go out and get 2 new ones because, believe it or not, 2.5 and 2 3/8 fit right here. On the outside and the inside, maybe, I think probably both. So every hole saw size doesn't necessarily fit. You kind of have to skip every other one. So this skips every other one that would fit in here, and here and there is the same story, because you get to a point where they can't actually pass, even though this is the next size. This is the syndrome. You know, the next size doesn't fit because the teeth are splayed in and out to make a nice kerf, so the inner tipped teeth just get in the way of the next size. So that's what you end up with. Anyway, I need the ones that go in that open space there and probably the open space there. To try and find out, for a nominal 2-inch pipe, I know it's 2.5 outer diameter, because I know Sked 40's got a 1/4-inch wall basically, but I drilled a 2.5-inch hole saw and a 2 3/8 hole saw hole here to try and figure out what I want. So we go to 2.5, and of course it's a nice fit, but there's some clearance, and I don't want that as much as I want to deal with. This is 2 3/8 once I'm in it. My notch neck's down right here, but once I'm actually in it, I'm loose again. And that's actually more of a line-to-line fit. And that's what I want, especially for side to side. I don't want a lot of slop side to side in this assembly. Because that subtly changes the weight balancing. And it is going to create in everybody's inner ear a sloppier, less reliable or safe feel, I think. I think every little bit of change that you can get side to side over the pivot is going to create a problem here. And I think, the motion that we want is just around the pivot point. We don't want any other collateral movement. So we've got a, more rigid than possibly what's necessary floor system, more rigid than possibly what's necessary foundational sort of component. I don't really have good names for this stuff. In an attempt to limit the degrees of freedom just to that pivot and to the wheels on the floor, and no other collateral twisting or deflection or movement of any kind. It can always be added if we think that we need it. So again, for now, I couldn't be certain to go to the store and pick one or the other. I'm glad that I did get the 2 3/8. I actually waffled on it. But it's going to be the one that we use. So I've got those locations marked out here. So we'll do 1, 2, 3, then we'll flip this thing and do 4 on the other side and finish, cutting into them with the jigsaw. And it does need the angles, which I'll probably put those in when it's on the floor. Everything's on the floor. That keeps it, I don't have to have another set of hands to install those. Install those, throw those in there. And then we'll do the 2 3/8 hole through the posts from both sides using that hole that we put into it yesterday for the pilot. And we'll probably have to smack it through the one and into the other with a hammer, soft blow hammer. But I think it'll be worth doing that. Also, does it spin in the post, or does the floor system spin about it? I'd really rather it wasn't turning in those post openings if I can help it. And that may mean that I have to drill into it from the end at an angle out the bottom or out the top, and then run a screw at that location into the wood, just so not everything's turning all the time. And then we're going to have, this much showing, however much, and I'll put a cap on both ends just to keep everything from moving around and away. So I really don't want it to be turning because I don't want the cap or anything coming loose. Just got some things to think about here. For now, I'm sure of the hole that I want to drill, so let's do that. Well, that's how you make a nice concentric hole through something real thick and solid without chewing it all up and turning it into chips, which is what a Forstner drill is going to do. It's what, a lot of different things, and it hasn't got a pilot, so it's really hard to keep it aligned. Hole saw is nice because you only got to turn the kerf into sawdust. The rest of it can just sort of come out in one piece or several kind of pieces. You see me break off and remove utilizing the failure of the grain. Once I've bottomed out the hole saw, got to get that material out of there so I could drill deeper. I did immediately get done talking about this notch and the 2 different hole saws, and then go ahead and drill the 2.5-inch hole almost all the way through for the first notch before I realized I had been saying I wanted to use the 2 3/8. I knew I wanted 2 3/8 for the post to limit rotation. Since I was most of the way through the 2.5, I did 2.5 on all of these. So we will have a little collateral jostling in that, but we've got 4 different notches, and however careful I was to lay them out and to cut into the square them up, they're likely a little out of alignment to some degree from the drilling and from the sawing. I did measure that location on every one of these joists and checked that I was roughly center, maybe a line weight, and just be as careful as I could with measuring. You could have done it in one place or the other and hung a square down, but that would be supposing that this whole assembly is square, which it isn't yet. Once I put the plywood onto it, it will be square. So safer bet was to measure to each location. So I've done everything I can here to limit alignment discrepancy, and I went with a slightly larger hole so that the last little bit is taken out in that, and I think that will be fine that way. I don't think it'll be too sloppy, and worst case scenario, if I have to, I can literally just drill the 2 3/8 notch through this whole side, slap the deck onto the top. Yeah, we're missing 2.5 inches of meat on the bearing, but since we're screwing in plywood, we're holding this from being able to open it all and break about this notch, which is the way that all the straps and stuff that they sell to fortify joists for plumbing situations that have to notch a surface like that. Which, I don't want to get into whether or not it's code compliant, but basically that's the thing. If it can't break about that point because it's been tied together across the top, doesn't matter that the material's missing. So I have flexibility there, basically. What's up, guys? So, in that, I'm going to finish drilling the 2 3/8 in the other post, and I'm going to try and smash the pipe through. It seems to come tight on the threads, which are tapered, so I assume I'm going to have a heck of a time packing the rest of the body of the pipe diameter through here. So hopefully that won't be the end of the world to get done, because it will mean that I have to move all the way down the length of pipe through one opening to get to the other, and it could be awfully rough on this assembly to have to beat it with a hammer and to be, smacking it up so hard. So let's see how that goes. Well, that made more sense to take down. I think right to start with, I don't have the side braces, and I'm not a part of one long stick that's controlled well at the end for vertical. Over here, it's a lot wimpier, and so anyway, just popping it off of there. I also realized that I won't have to drive the pipe, all the way down the length of the pipe through one hole to get to the other, so long as I can smack the pipe into this one as far as it needs to go. Or possibly even install it into this one first. Anyway, and then put it up. And then when I get where I'm going with the bottom of it, I'll put it back down. Another thing you want to realize is that these are wet, and they're recently pressure treated. So that is a bit of help in the cutting, in keeping it cool. The alignment of the 2 holes is pretty good. You can see that's a touch off. And that's about, that's to do with heat, sharpness / dullness, and the deflection that you can get out of that center drill, and some other factors. So there's a variety of things that you can tighten it up even beyond this, but for now that works well for us here in the field for what we need. You also want to be aware that it's going to make this crud. As soon as you reach down in there and go around a couple of times, it'll make this cake crud slime goo, and it fills the teeth, and then it's just burning that up and smearing along. So it's actually easier if you pop that first part of the hole out, after every inch, almost half an inch to an inch, and keep removing that, because then to the inside of the hole saw, you can't evacuate that goo to the outside of the hole, but to the inside, it's a negative space, and that can be moved into there, and you'll notice immediately that it'll do a lot better cutting when you're not down in the middle of a crevasse with solid wood inside and out where there's nowhere for this to go. I'm also packing, which is coming coming up clear out of the material, then back and out and back and out and back. And that's knocking this off and clearing it. And I'm also stopping sometimes and just tipping it, and knocking it off of there. You want to be careful. You start touching cutters because you trust yourself to stop and to start, and you get into a habit, a pattern, and next thing you know, it's running when you touch it by accident. So you want to be thinking. But I'm fairly certain that this is going to work for our purposes, and I was able to put it through there at a nice 90 degrees within the tolerance of this type of stuff. So let me see if I can't get the pipe installed and put that back together. Have a little drink here, have a little think. It isn't often that your old pal Chazzy finds himself a little bit stuck in the mud. Why is that? Because it used to be pretty often. In fact, my journey has been an exercise in simply mitigating the frequency getting completely held up on a project, because the more that you learn, the more that you can basically avoid things that happen to you once and never let them happen again in any modified form. So friction and increasing the friction. I was talking earlier about having to slide that thing all the way through before I realized I could take it apart. And that was where I was thinking about, you really start to, it's cumulative, but I didn't realize that just making it, I should have, but just making it through this post, we're increasing our frictional interaction at every little bit, basically. So when it was tough moving initially, I should have really thought about, it's just going to increase, it's going to double after we reach the halfway point. It's going to get to be twice as difficult. So that's where we are. We're not able to get this to go through the wood any farther, and I've got maybe like a half an inch to go on the bottom. Yeah. So we're there. I started out on the frame, then I went to the floor, which is more rigid, with something like that, so I could go right on by this plane when I get there. Wishful thinking. And so I realized I'm going to want caps anyway, and I did a quick search. I hadn't thought there'd be anything like this on the shelf locally. It's really getting into some professional size stuff when you get to 2-inch pipe steel, but they had them. They have a few. The Ace Hardware franchise has a few, a dozen fittings or so, and some nipples and whatever. So I was impressed. And it would also give me something that if I were to thread it far enough on there, then I could get pretty serious about hitting it without screwing up the threads that I'm going to need to put the cap on when I'm ready to put it on finally. But hand tight only wants to go so far, and it really isn't enough thread engagement. In fact, I did hit it a couple times, which leads to my next problem. When I hit it with the steel hammer, you can see the little dingers that I put in there. So it's not going to take much more of that. And if you can, there was before on that first thread, I guess there's probably the best place to see it. On that first thread, that's that showing up visually is the result of it being a little deflected from only having been spun on a thread or two and hit. There aren't enough to resist that. It was loaded on far fewer threads for not being able to turn it on very far, and they actually moved a little bit and smeared when I hit this. So between this structural integrity problem and the interior structural integrity problem, not going to be able to get much more serious with those, but we still got to get this there. So the natural evolution in the thinking is press, just peacefully apply incredible force rather than violently. Okay, well, this is really big for things like that. I can lay it down in a narrow space on the floor between two robust walls, which we have around here, and use a hydraulic press like a bottle jack or something like that to push it. but it needs to move through and out the other side. So whatever I'm backing this stuff up against has to have like a socket or an opening, or the way that I took this panel out of the floor to support as close as possible to either side in this material, but to let that pass through to the degree that we want it to. So we've got to have that type of a physical situation, which isn't going to be easy to find. Which brings me to my next point. How far does that nipple need to be pushed through there, that pipe? It's a glorified nipple, it's really long. But how far does it stick out? Well, we know that the inside face to inside face dimension needs to be the same as that 22-inch stick that I made there. So it needs to be 22 inches between the two posts, and they can't be clocked to one another. So we'll do this against the floor or something so it stays flat, or it'll have to twist, which it probably will be able to. So we'll have to keep them flat, slide them together, and expose a uniform amount of the threaded end of the pipe to either way, and put it together so that I've got exactly 22-inch distance between the two, having taken that out, done so on the floor somewhere in here, and then lug the whole thing back and put it back in here upright and run the screws and stuff back into it, and then resume building. And that means more taking apart first and then trying to put together. And then, because that's the bastard that I haven't figured out yet, really. And then when you're there, there's the third leg, there's the decombobulation, the actual problem itself, and then putting everything back together again just to get where I was about to be. So, do I wish that I had used the 2.5-inch hole saw to do this? Almost. Not quite yet, but almost. So, and it was in making that decision with that hole saw, like I slipped into it because I didn't realize what size I still had in the drill when I got cutting. So then I thought, well, of the two components to be overly loose, this is the one to let it be that way. And I had already cut through most of that first stick, so I could have cut the center out instead and kept the hole size smaller, but it would have been like a little crescent piece of trash that broke out of the opening. So it was in for a penny, in for a pound there. Obviously can't drill it any smaller. Actually, the other more major problem is this isn't going to be easy or really possible to drill any bigger. It gets to be really difficult. You end up wanting to put the next size hole saw on after the hole saw size that was used here, but it's nice to have a deeper one so it can get started in its own hole before you start the other one, and then you're trying to follow and keep it normal or perpendicular to the face as we already have got. So unless I want to turn those over, go back down and pilot drill the other end of them, repeat all the drilling ops and just use a bigger hole saw through these other ends. The thing is, I really can't get this out. That takes us home. I really can't get that out of there now. We've got a significant expense in that pipe, and there's no pulling operation. You really have to push on the other end of it. So you got to get something that'll go in the hole in the wood, but definitely, butt into the thin end of this thing and not fall into the center of it. So you need more 2-inch pipe. But the problem with this situation is the 2-inch pipe doesn't fit into this hole, and the next size down would go right inside. Would go right inside this pipe. So you can't just go get something easily that you can push on the end of this pipe with, and you're back to the same point, really, problem of, I can't push this in any farther. Yeah, coming back out would maybe be a little easier, but I still haven't got an easy way to do it. So, like I said at the beginning here, it isn't every day that you get old Chazzy stand on his neck with his face in the puddle. This is a good one. But it is also at this point that it's time to just persevere. It can be discouraging. This has been going pretty slick so far, but I have been thinking the last couple of days this show's got a lot of stuff to realize fully. And, I've got 3 weeks, kind of. So we're going to have to turn the heat up on this and try to figure it out quick. Okay, so popping those diagonals in will be worth getting done. Then it's just out of the way. They're a touch over. Well, actually, it's not as bad as it looked. Sorry to anybody who doesn't like the sight of blood. It's just a tiny little poke. Tiny little poke. Right almost exactly in the joint between these two finger bones. And it was because I was using my hand this way to push, manipulate this in, and running in a screw here that I was picturing being at this angle, but instead it was at this angle. And so L finger, yeah, something I'll never forget when I started doing this residential carpentry kind of consistently, working for other people. A lot of the guys were just super gung-ho, and like as soon as I got a screw started, would just rip it, just run it as quickly as possible, just going like crazy fast. And you wouldn't believe that you could screw your own finger. Nail gun, shoot a nail through your finger, yeah, but that's how you can screw right through your own body, by just having a habit of being like, as soon as it's ready to rock, just running in as quick as humanly possible. So just bear that in mind, especially with less experience, but even with more experience, the more comfort you have with something that always seems to work. I might have just being as safe as humanly possible here with all the other equipment and things to avoid getting hurt with, from touching the hole saw to clear it, to, cross-cutting with the circular saw, different things, to run a structural screw right into the joint. At least it'd be my left hand, and second finger in from my index finger, but still awful injury to have today. And we avoided it by just not being a ridiculous asshole when it comes to running power tools. If you can manage that. What was I saying? I didn't realize that these came in a little over 48 inches, which means the two of them wouldn't come out of an 8-footer, which is what I bought for them. And the other two pendulum sticks that double those were going to come out of this 10-footer at 52 each or whatever. You get two of those. However, again, more than 48 inches, so I'll have to take at least one out of the 10-footer, and that's about all I should do, maybe, because it's so checked in from here. If I took primarily the good end, I'd still need somewhere here, and it would be still pretty checked, but in this application, maybe not the end of the world. However, over here, this area should have been lopped off at the sawmill. Sorry. That's like burl almost, but it's the bottom of a crotch between the trunk and the two major branches that split off of it. The one goes left, the one goes right, and this is a crotch that goes right down in. And it's just, the grain is shit here. It's Douglas fir burl for what it's worth. So there's much less than 8 feet here. So really, I probably just make the other piece I need from the end of this stick and call these two just the junker. This is what you get when you buy kind of exactly what you figure you need for a lumber order. There'll be enough stuff just in half a dozen sticks of this material to, even if you looked at it yourself and picked them out. I don't know how I missed that. I don't know how I missed it. When they're wet and stuff, it changes how they look. Sometimes that crack probably popped when it came inside and started drying and warming up. But anyway, so there's a little lesson in, buying lumber, and even if you're looking right at the pieces you think you want, you're going to be in a position later where they're a little different maybe, and paying attention to what the fuck you're doing and not, harming yourself or others if you can handle that. I actually took that component outside to, in the 6 degrees that it is out, just so set it outside the door. See if shrinkage helps anything. I don't know at what point the treated lumber freezes, probably right around 0. That would maybe expand, but the steel pipe, I'm counting on that to cool more quickly and more significantly and shrink down, and then maybe it would get driven through the hole more easily. So we'll try that. But so for now, I'll make the other piece I need in the diagonal and pin him together, and then we may be at an impasse though. I'll keep you posted. Well, as much as I'd like to put that piece up on the other piece, spin it around and tip it up and down, just get a feel of it, I haven't got any help, number one. And number two, the wheels we ordered show up tomorrow, so I may as well pop them on there. And those extra blocks, the pendulum legs that come down to the weight, have to have a hole through them. And they were supposed to be threaded onto that pipe, which is a bad design. I don't think there's any real reason to do it that way. So I guess they'll get a hole and then a deep notch, so that 1, 2, 3, 4, everything outside of the opening can be laminated to translate with the biggest possible layout of hardware, that 90 degree. And we are going to brace it on an angle. So yeah, the only other option would be to make it a wildly even deeper notch and go around the top. Well, you could go through the side, but that really compromises 2/3 of the grain, and you end up with just the 1/3 on one side. So I think it's going to be the shallowest of all the notches possible to the extra blocks to put the pendulum arms on. And then they'll have to be added after that's up, slid into position and screwed in. But is there room? No. Yeah, this is the danger of designing in the computer. Where's my drawing? They go tight to these 6x6s. On the inside. So then you could screw from back here into this joist. No, looks like the joist is coming down. No, it still won't work because it's got a hook on from above. Yeah, that's a real... Got yourself good there, Chezzy. So... I can run a screw in from this angle, here and there, and from above, here and here. That'll be how we have to pin those. That's all right. Yep. That's a humdinger, but it means we can just continue to move forward, which is good. Yeah, so we'll get her. And then, do I want to do that? Yeah, before I add any braces here, because I'd just as soon probably be shorter, quite a bit shorter with the bracing rather than this, because I can't go anywhere that keeps me in alignment. So, yeah, an interesting, simple, but in getting it into real life, I mean, these are some of the biggest dimensional sticks. 16 feet is essentially as long as dimensional lumber comes, unless it's a special 18 or 20 footer. 2x12 is another one before you go to glue lams and LVL. 6x6, the other, sort of biggest fundamental, commonly available construction component made of wood. 2-inch steel pipe. That's a pretty darn good size, getting to a point where nobody had the ability to really handle it. Locally. Anyway, I don't know where that glitter came from. So, that being said, the fewest number of components and the most effective construction still had me taking it apart a little bit, dragging it all around a little bit, considering, taking some stuff apart here and massaging it a little bit. Went backwards a little bit here, but overall forward. And now we've got to get it up and running. And then I got to be sure that this trapdoor will take it, especially with people on it and everything else. And if not, I may have to install a structural component underneath here when we're sure that we're done using the trap. Or just commit to it so we can start rehearsing and just not be using the trapdoor anymore. That would be a bummer. Because I think we're going to need to come through and go back, and this is a very weak area as compared to the rest of the set, or the stage, which is concrete poured into corrugated deck like you do. So yeah, so lots of considerations with this, even though it's a relatively simple thing. It's going pretty smoothly. I've got to add a surface to it, which again, with the weight of everything, I'm starting to debate if I want to even try to go to 3/4 again. 5/8 would probably be a nice balance. I'd probably get some 5/8 OSB, something cheap, roof deck. So it's gonna have to sit here. I cleaned off again so they can dance in the morning. They can walk it out of here if it's in their way, which I'm sure it is, but I'm not walking it out myself. And then we'll get back to it. Try to get it up on there with some help from some students and discover, you know, how unwieldy it is. I don't know, it seems pretty good. That's too narrow of a wheelbase. I did notice that when I set it back up, the toddling around, but as soon as I put a wheel underneath what's almost a foot greater in width, it's gonna add quite a bit of stability. All right, back tomorrow. Well, here's your view from the poop deck. I'm at 66 now at my feet, obviously, and another, I don't know, 58 or something to my eyes. More importantly, we got this piece onto the other before everybody ducked out. I've got some angle to pick here that will likely have to do with bringing in the half of that tower roof made of cardboard in the basement along here and completing an arc that ultimately swings out to a point here and doesn't just go around the corner smoothly as a circle, but has an actual point with a bow kind of line. And all of that is supposed to cut under, which is why this corner is clipped back in the 6x6 so that it can cut under more dramatically as it goes around the corner here. And you know, I struck a balance between losing that footprint there at the outside corner and knowing that the weight here across the pivot is going to be counterbalanced over there as well as below, so we could get away with something like that. So this angle is going to change as a result of getting this whole thing to swing around. I've got to get that cardboard roof section up here and cut in half at some point, etc. These stair sections will have to attach. That wedge will be built, onto them so that the side of this doesn't have these further like barbs or whatever sticking out, or at least it most likely will. Yeah, because then this whole thing is free to just, it'll be added to this. And then we'll, finish the side of that all together. This set piece will stay more streamlined and less complicated, especially for the tipping action, which works nicely. I've got the rest of the geometry that's laying here in rough lumber form to add to this today, so that I get my positive stops and my pendulum arm hanging down and some kind of a pivot chosen for the weights. I haven't gone to the weight room to measure what we actually own, what would be the easiest thing to use, likely a smaller size piece of pipe. And I've also got a surface to put on top here, but I think right to start with is I'm going to get through the last couple. No, that's right, we came to the end of the 2x12. All we had was junk left. So I got to get a lumber order for it's going to end up being 252s, but then 2 short versions to pack it out to flush. And then we're going to have 4 diagonal braces that aren't shown in this to brace those pendulum arms up to this flooring, so we aren't just bearing the weight fighting the pendulum weight and twisting the connection here, but we've actually got triangulation happening. That's what we need there. So I got to work out what lumber, and that I had 2x8 planned for the positive stop. Just never hurts to go with something stronger, more robust. That diagonal, I feel like that could be 2x6, and maybe the stop could be 2x6. It's hard to say. It's vertical load. I don't think that it really needs to be. It might even be able to be 2x4, but it's just we err on the side of caution for a few dollars more. I don't want to have to find out the hard way. Anyway, I've got to run and get some lumber and then come back and make those pieces. I suppose if we're being fair to the facility, we've got a pretty legitimate weight room facility. This was actually the architecture lab, and this has had significant construction since then. When I was here, that's what this was. But I just think that, I'm not boasting. It's mostly about just being appreciative of public school, especially right now, and the variety of things that this little community has access to. Nothing's perfect. State of New York leaves a lot to be desired, but this is the type of thing that if I make a record of it now even and keep on it over the next coming years, we'll see what types of improvements or lack of improvements there are. And then this is the kiln for ceramics, which I think is just getting started. Looks like we got a little door seal problem there. But they're going to go back to doing some weaving stuff there as well if they get into doing that type of a thing. So anyway, I got to measure up these weights. Shear, and must be some other shop. Almost looks like silk screens, but they're not. This is art supply more than athletic, or maybe a little mixed together, but this is what I'm picturing using. And here's the 45s. There's a pack of them there. There's packs of them down there. There's again here, and that everything goes over nothing over 2-inch diameter. So we'll have to get our hands on something. Now these are rubber 25. So there's something to be said for everything slipping. Nothing bigger than 2-inch. 2 inches is probably going to be too tight of a fit. But there's a variety of things that we're going to have to ask and borrow and then transport down to the set and back. But I got an idea now of what we need for a structure to load those onto. And so now it's back to work. Okay, so if we're putting those big plates in here, it moves the center up far enough that if this is 52, quite obviously 48, it won't hurt to be an inch or two a little bit higher with the weights overall for, the utility of using an 8-foot stick to make these two components. In fact, to make the other two as well. So 2 8-foot sticks. I do like 2x12 to make sure that I've got the biggest amount of meat. And, again, we're going to have to notch around this. So we're actually going to 2 strips on either side of the notch for that pivot. So the 2x12 is going to be ideal. So we got to have 2 by 12 by 8 foot pieces for that. And then these diagonals here are essentially the mirror image of what we want to use to brace that pendulum. And we know from our drawing on this other side, they're the better part of an 8-foot stick. So I think we're having one on either side of each pendulum for a total of 4 8-foot sticks. But what of? I'm fairly certain that 2x6 will do us there. You wouldn't believe what 2x6 will do. Quite often it's a rafter in so many old homes, given a certain roof angle. So I think 2x6 is safe enough here, and I think that it'll also work for us as a positive stop. However, in that application, I'd probably rather use a 2x12 just so that there's the absolute largest amount to make it one single component working in this way without its own diagonal brace, which it would be totally possible to do. It's a really dumb conundrum to have. It's going from this surface down to there, and you've got the ability to land a good width. I think that there's no reason to skimp here. I think the 2x12 will be used there just because it's just extra safe. It's essentially all the same operations on a slightly more expensive stick. So we know that we need, we're gonna need, will 60 do it? I think so, because 66 from the floor, and we're gonna take out the 5 inches and the 5.5 of that 6 by 6. So ostensibly, if we're real close to where we need to be in this elevation now, yeah, 55 would be a full fit, tight fit, and obviously we're cutting it short beyond that, you know. But would we cut 6 or 7 inches out to travel 6 or 7 inches here? That's, you know, that's 7 inches there, and maybe that is how much we're going to travel to make this ship look like it's sinking. And so that means we could buy an 8-foot stick, cut it in half, and use the 48-inch long halves of either end. Or will we buy the 10-foot stick? Since we're doing the travel, we're buying it, we're loading it, we're bringing it back, we're loading it in here, we're cutting it in at 52, and if that seems like everybody can handle it, then we can always cut some more off. Maybe that's the wiser decision. So we'll buy a 10-foot 2x12 for positive stops, and maybe you see it's worth, you know, crossing these bridges. So we'll buy a 2x12 by 8, a third one. So we'll buy 3 of those. And then we said we were going to buy 4 2x6 by 8s for the braces. And so this covers our pendulum arms, our positive stops, our angular braces. And I guess if we got a 16-foot long section of 3 feet wide, we've got 2 3-foot wide rips of a 4x8 sheet of 5/8 material to make a deck surface. So I'll make a pass in the basement to see if we haven't got any, and if we don't, I'll get 2 4x8 sheets. I brought the pickup today, so today's the day. And if we could get that stuff, come back and install it, the fundamental parts to this going. The wheels haven't gotten here quite yet today. I got thinking that it doesn't have to be flipped over ever again. I can just roll it out over the trapdoor and work up to add these wheels. I've done it before. I can do it again. Various pieces. It's nice to have this basically service hatch located in here, but I think we could get this thing really functional today if we were to get the material, get back and install those pieces and not run into any headaches, because there's enough left to do here. We've got modifications to those stairs. We got to come up with a way to connect the mast so that when the deck of the ship tips, the mast is also tipping. It's going to really play up. That's going to actually help even more with everybody's body going up and down in this regard. That going side to side is really going to help visually, and it means it has to be off the floor probably a couple of inches so that when it swings on the radius, the corners of it don't scrub the floor. And then we'll probably use some of that fringe that we used to clean up the edge of that rolling circle last year. It was supposed to be a rug, so I put rug fringe on it, but that fringe also works in an application like this as like a skirt that just won't get kinked or messed up. It should always kind of hang vertically, and from really far away it completes that to that shape to the floor with a minimal shadow line. Like I like to see a 1/2 inch, always less than an inch. If I go over there, we're getting to be kind of a big shadow line. But as far as problems to have, minimal. Anyway, that's just a general overview here, and I won't get the other set of stairs out of the basement until the students are back next week, but I would like to be to a point where that thing is safe enough to be on top, and the stairs, at least one set, will roll up and connect to it, so you can go up and come back down and start getting a feel for the whole scenario. So we better keep kind of pedal to the metal. Well, I needed a couple more feet on that mast, and the frustrating part of sonotube is that it doesn't really have a good manufacturing tolerance. We've gone, these are supposed to be 8s, 10s, and 12s, and we've got 3-layer telescoping situations happening, and when they're out around, no measurement will give you what you need to know. So I'm going to have to do a circumference with a textile tape measure on our tube, and then come back over here with that same tape measure and get the same circumference to the best of my ability with before I can make a purchase. So I got a 34.5-inch circumference at the one end. I expect it's the same down here, but we'll just see. This is an awning package. It's got sawdust board in one end. This is an awning package, not a sonotube. So you could expect that there could be a discrepancy in manufacturing common sizes. That's close enough to 34.5 for me. However, we saw at the store, there's a variety of sizes there. For each nominal size, there's a variety of actual sizes. And we want the outside to work out coplanar and be tapeable and sort of disappear. So I'm not going to put it up there. I'll add 2 or 3 feet at the bottom and downplay it by putting it low. But like I said, we'll make things easy for us. So we're looking for a 34.5 at the store, and we're also going to get a 24-inch, 1.5-inch nipple. It's 22, we know, between the verts. It's my head, but I can cut it. And so I don't think we're going to get this far away from, if we stay to there, we'll be in front of that pipe opening. So there's a chance that I've got to cut a clearance through this first layer and then put a cap or something in there. If it would be, that's the thing, is like you have to get the whole cap to go in 1.5 inch thickness. So anyway, I just don't want the pipe coming out one way or another. First thing it would do would be to jam the movement of the piece. No bueno. Secondarily, catastrophic decombobulation, which isn't likely, but I still want to do what I can. More helpful. It would be more helpful to get some clamp rings. If I could get some that would work on the outside, then we can just put them on the inside face to keep the trap side to side. Because I don't think the overall thickness of the weights is going to come close to filling the space. There'll be room to positively stop that. So we'll look for some positive stops. I got the 45-inch discs here. And from what I understand online, people that build their own stuff for weightlifting, they get away with 1.5 inch pipe through the center of this Olympic plate weight. It's a 1.95 diameter, and pipe is supposed to be 1.90 actual diameter, 1 inch 0.9 or 1 inch 0.95. Yeah, so anyway, we gotta have a little bit of clearance, and we gotta work out in that fashion. So we'll get ourselves a nipple that will be cut down. We'll get some positive stops on it, and we've got a hole saw to cut that size, but I'll be sure that we do. And we'll get the appropriate amount of sonotube, and then we'll come back. Okay, it's actually a sloppier fit than I would have expected, but that's fine. It's essentially the right size without being annoyingly too tight. So now all I gotta do is cut this thing to length. Well, that cold cutting saw is really something. I gotta get me one of them. The blade has got teeth like any other circular saw blade, but the speed, I mean, I went through that in like 5 seconds, maybe 10. Everything's cold to the touch. Nothing stinks, and there aren't sparks on everything laying around trying to start a fire. But I don't need one all that often, and most of the time it's when I'm here and I just use the schools, but still, real nice piece of tech. All right, let's go put this in place and see if we can't get a counterweight to work. So, I think I've immediately realized something that took making this in real life to really realize it. But all the lower I can get that weight pack, all the more effective its purpose will be here. Actually, for the width here, I need it to be as long as 1/2. Obviously quite a bit longer, and it's even more stable. Basically, as the lever arm grows in its relationship to this lever arm from the pivot to the extent of it, the stability with the same weight is increased. And so I think that it would behoove me to reuse that 22-inch piece over here, send the left side as far as it would go to here, it's still 22, and put this angle on it and pin it there, and make another one on the left so that I could drop the weight kind of way down, another foot at least. I think that the center line could be, close to a foot lower. And I think it would be well worth it. Unfortunately, it makes the two 8-foot 2x12s unnecessary. Although I might be able to find a way to use them elsewhere in the construction here. I think that's going to be important. Adding more weight is also possible. So I'll start with that and see what that does. And I think to get that done, what I'm going to do is, if you move out to where the pipe will come sliding out. If you go a little farther here, somewhere, some thickness of 2x10 could be put across between the two 6x6s, and all of the weights could sit right onto it. And rolling forward or back, we would find a place where that opening lines up with everything. And basically, you wouldn't have to support all of the weight. It would just be a little bit of trial and error, and then we could make some pencil marks on there. So if we need to make weight changes a couple more times, we could get back there pretty easily, but it would take more hands. So I'll wait until students are around to help with that. It would still work like that if I had to add a few layers to the floor. If I'm dropping everything a bit lower. I got to do a little more, maybe do a little math to see how much of a benefit I could gain. So I'd rather not load that whole thing with weight if just dropping it down, I could use significantly less weight. Because the weight objectively makes the whole thing weigh that much more. It makes more trouble over the trap door. It's just more trouble overall. So I want to do a little bit of work with math to figure that out there exactly. But for right now, it does what it was supposed to do. It just brings us back with a little bit of friction, so I can wax some things up with some paraffin wax. But it kind of comes back to plumb, which really wasn't its purpose. Its purpose was for somebody to be able to stand out here and for it to resist, this. So I can push here, and I think that amounts to it's a good question, how much weight? This has got some weight. This probably weighs 10 pounds. So I got to do some math. The relationships between the weight that I have there and the weight that's here, and just the ratios would be easy enough to figure out how much more weight it's going to take. And I need to talk to who the students are going to be on it and how much they weigh. But I think the fundamental parts are here. So at this point, I'm going to call it and pick up tomorrow. I got to get the mast and get that to move with the rest of this thing, and some other. I got to brace that other vertical. I could wax things up again so it's quieter. I got the deck surface I can put on it, and we'll just keep plugging away. I think what I need is here. It's just a matter of test and tune now, or let's hope anyway.